Hello, my name is Oren Manor and I'm from Siemens Industry Software, and I'm going to take you now on a tour to show you how Siemens is digitalizing manufacturing. And what we're going to see here in this tour is really how Siemens is helping by the digital twin concept, digitalize building a machine, building a part, configuring a line, and doing a full process or discrete manufacturing process, as well as how we're using local startups as part of Dynamo, our local innovation program, in order to embed these startups into the different Siemens divisions and bring very innovative solutions into the market. Now, as you know, we have taken electronics manufacturing kind of as the theme for this tour. So a lot of the different stations will focus on electronics manufacturing. And what we're going to start with is around additive manufacturing. And Siemens has been playing a very big role in additive manufacturing in the last couple of years. We've launched the additive manufacturing network, where we're bringing in suppliers, part makers, OEMs, designers into a network and into a common platform in order to really connect all of these elements together. So, and you can see some of these parts here. We're going to show here two solutions, one coming in from Nanofabrica, which is really doing machines with very precise additive inkjet solutions, as well as Cyborg, which is dealing with counterfeit components in electronics manufacturing and finding those counterfeit components with intelligent software. So this is the first station. You can hear about it here there.
Hi, I'm Tovit from Nanofabrica. I'm the VP Business Development. Nanofabrica produces and manufactures 3D printers for precision engineering. We're reaching 1 micron resolution over a relatively huge build volume of 50 by 50 by 100 millimeters. The first part you can see on the screen is an assembly for antenna. This one was made through injection molding. The part itself, the mold itself, was made on our machine. The diameter is 1 millimeter and the resolution is 1 micron. The time it took us, the lead time for a mold, a printed mold, was 20 minutes. So that cuts down significantly the lead time that you're waiting for a metal mold. This one is coated with a 200 nanometer coated layer. It's an antenna. The part you can see here, the tiny one, is a part that was injection molding to our 3D printed mold. The mold itself is here. As mentioned before, 1 millimeter diameter, and the resolution is 1 micron. Nanofabrica is part of Siemens Additive Manufacturing Network. You can go onto that network, order parts from us, and examine our capabilities. Thank you so much.
Hi, I'm Dr. Eyal Weiss. I'm the CTO and founder of Cyborg. We assure that no malware components or counterfeit components enter your product. We do this by AI big data analysis of the components right before they are assembled onto your boards. Everything made of electronics is basically made of electronic components. Now, how can you tell if you're using only original components? There's no way of knowing in today's technology. There are so many types of components, so many manufacturers, that it's basically impossible to check them before they're using. Nevertheless, 5 to 10% of all electronic components are counterfeit. This is an amazing number. It means that in average, in every board, there's at least 1 or 2 or 10 counterfeit components. Now, a counterfeit component can be low quality product. It can be an old product that was dated to look like a new one, or it could be a recycled component, or it could be a malware, basically a component that was engineered to perform an attack, a cyber attack, on the system. If you look at the images, this is, for example, a capacitor. They all look the same for the naked eye, but to our AI big data algorithm that uses forensics to detect very minute changes and very specific fingerprints of each and every one of the components that you use, you can verify every component that you're using before they are assembled. Thank you for watching and hope to see you soon here.
So you've seen how what we do is the parts, and here we're really going into the machine part. And in this station, we're really going to talk about how, first of all, a machine is configured and built using some of our solutions from factory automation and motion control. And then later in this station, we're going to show you how augmented reality and virtual reality can be used in order to help with maintaining machines, servicing machines, as well as building these machines with much more intelligent work instructions.
Hello, my name is Eran from Siemens Software Innovation Team. Here I want to talk to you about AssistAR. This is a new product that jointly developed by Siemens Software and an Israeli startup called Skillery. This application is using augmented reality, precise and robust, taking the digital twin of the model of the entire process of assembly, inspection, and maintenance. What it is do is taking the model and project it on the real object using this precise technology. You can see here that the operation can see step by step the next step and the next step to do. What you can see here is the model is being tracked by the sensors, and therefore it's always looking on the right place. What this technology can do is reducing dramatically the number of mistakes. It's improving the overall efficiency. It's speed up the training time for new employees, and it's reducing the need to create work instructions because the operator can watch the screen and see exactly what to do step by step, like rebuilding a Lego, very simple way. It agnostics to the environmental, to the lighting, to the object that is being tracked because it's tracking the camera. So again, this is the AssistAR technology from Siemens Software and Skillery, and thank you very much for watching.
As you know, Siemens makes a lot of electronics components, and we have one of these devices here, which you can see here. And this device is actually an electronic edge device called the Nano Box. And this is made in one of our factories in Germany. It's a fully automated production line. And here we're actually showing a robotic solution which can help us to really automate manual assembly. So components which traditionally have been placed using humans can now be done using machines and robots. And here we're also showing a partnership with Artimines. And there is an AGV, if you can show it, that's running here behind this. And this AGV can really help us with later on taking that device and taking it to the next station to really fully automate the discrete manufacturing process.
Hello, good morning. My name is Rav from Siemens Industry Software. What you see here in this station is a continuation of the first station that you saw where machines were assembling small components, electronic components on a PCB board. Here is the next step of this process where human operators are traditionally assembling these bigger components on a PCB board. What you see here is a cobot equipped with a force torque sensor, a gripper, and Artimines technology behind it. Artimines is a German that developed this technology, and we embedded it in our software in Siemens. This technology enables the robot to sense the forces during the assembly process and compensate to complete the assembly process. As you will be able to see here, when it goes down, it searches for the hole using a spiral search, which is unique technology, senses the center of it and releases in the right place. The result is that you are able to program this station without writing any code. You just use templates. Thank you for visiting us here at Siemens booth.
So we've seen discrete, and here we talk about the process industry, and we have a very nice example here of a beer manufacturing site, and how we can actually visualize our manufacturing process and simulate it using this digital twin concept, and then actually use it inside production. And this is what you can hear about in this station here.
Hi everyone, my name is Nir. I work as a product manager for Siemens Software based here in Israel. And welcome to the process production area where we mainly handle fluids. Over here we're going to show you today a beer production line. We're actually producing the Siemens brand beer, and we have this digital model of the whole brewery over here. So on the left we see the malt silos. Over here we have the process of extracting the grains, adding water, and at the end we actually have the fermentation tanks where it's very important to do the process in controlled temperatures. We call this in Siemens the digital twin of the production process. Over here we have the packaging area where we've modeled the shipment and the movement of these packages. What we've modeled here is a connection with this automation kit. So these PLC controllers actually control the real physical production line. What we did here is we connected these controllers into our digital twin. The digital twin will enable us to validate and make sure that our control code is accurate and correct. So what I'm going to do here is I have a belt error, which I'm going to activate, and there's going to be a fault in the conveyor. We'll see it in a second. In the real-time production line, we're going to have a worker that's going to fix this issue. For this occasion, I've created a button where I press and I fix the issue as a worker. And now the production line is still at halt. The reason for that is that the PLC controller is waiting for input in order to continue work. So I'm going to acknowledge that everything was fixed. The robot continues working, and now we validated that our control code is safe and ready to use. This is what we call at Siemens virtual commissioning.
We've gone through the part, we've gone through building a machine, we've done some discrete assembly, we've done process assembly, and we've really generated a lot of data. What do we do with that data? So here, I'd like to welcome you here to the data analytics section and to this MindSphere zone. Here we're really collecting all of that data, we're consolidating that data, and we're bringing it into the cloud, and we're putting it in the MindSphere IIoT platform. And here, we've really made this an open solution for our customers, for Siemens itself, and for our partners to easily develop applications leveraging that data. And what we show here is a number of solutions coming from Philip, which you will hear about how they actually help us collect the data, and then here from Precognize and how we can actually leverage that data to bring insights, and Anecdote, which again is really bringing us insight. And this can be around performance, utilization, traceability, and quality aspects as well. And is really an integrated solution for different types of manufacturing.
Hello, welcome. We'd like to present to you Fili Technologies, where our sensing technology enables customers to place nanotechnology sensing options on their facilities, on their appliances, monitor their applications, monitor their facilities, monitor their flow. The installation is super simple. 1, they identify the critical points within their flow. 2, they attach the stickers which have the sensors already pre-printed on them. And 3, they connect to the analytics platform. That's all it takes. That's why our printed solution is non-contact. It comes above the zero risk in installing it. Where you can place the sensors, you can put it on the whole flow, whether it's on a valve, a pipe, on connections, and on steam traps. The analytes, the information, the analytics you can get from the sensors is through all the line of the production of what you do. This is Feel It. The Feel It sensors give them the indication right away, non-contact on their product. Thank you.
Hi everybody, I'm Vova from Precognize, a Samsung company. Today I'll be showing you our product, SamGuard. So SamGuard is a predictive analytics tool for the process industry. So what's unique about us is that we're using a cognitive layer on top of machine learning. We're using the plant knowledge in order to provide a few pinpointed alerts for the operator in the field. So today we're going to focus on beer manufacturing process, okay? Especially the cooling area prior to fermentation. So while Feel It were able to collect critical parameters for this control valve prior to cooling, what we're doing is the system is detecting a faulty control valve and generating a fault. The fault is correlating between set point and opening position of the valve and the actual temperature and the pH measurement of the wort. Okay, so all this non-standard behavior is the ones producing the alert for the system. Okay, so this knowledge right here is providing the process engineer with enough data to conclude that this control valve needs calibration. Failing to do so may result in wort being too hot prior to fermentation and damaging the quality of beer produced. Okay, so thank you all. Vova from Precognize.
Hi everyone, my name is Yariv and I'm the head of product at Anecdote. What Anecdote does is business monitoring. We start from top down, monitor your business KPIs and enable you to make sure that all your business runs smoothly via anomaly detection. What we do is we learn your data set, establish a baseline, and then identify an anomaly. This approach means that you no longer have to set up static thresholds for your data, and you just automatically, through our AI algorithm, identify when something is wrong. We started by doing a small POC with Siemens in their factory in Hamburg, where we looked at PCB cutting devices. Now, PCB cutting devices tend to generate lots of dust, and then they tend to break down. What we did was basically start monitoring the data from the PCBs to see if we can forecast when these machines are going to break down. What we saw was that we were able to give between 24 and 48 hours advance notice that a machine is going to break down. On a very small sample of 18 PCB machines, this means a savings of 120,000 euro per year in one factory. What we did next was basically put Anodot on this device, an edge device. So that means that the entire anomaly detection algorithm and brains can write on this very small device in your factory attached to your machine, or it can run on the MindSphere central cloud from Siemens. To summarize, the big value that Anodot brings is by able to sifting out the noise. You start with billions of events coming from all different devices. We know how to make sure that you look only the ones who are business relevant. We aggregate and correlate them, so you only get the alerts which are critical for you to run your business. Thank you.
So this kind of concludes our tour here of the booth. I hope you enjoyed it and come back with any questions. Thank you.